The first type of proof that we're going to learn is called the proof by deduction. It is the most simplest. It is the simplest case of proof that we're going to do. Our goal is quite simple. Our goal of the proof by deduction is to simply show that the left hand side is equal to the right hand side. Quite simple, right? So when we're doing the proof by deduction, we have a very important rule to follow. The such rule is that we do not want to cross the middle line. What I mean by not crossing the middle line is not crossing this equation line. What it means by that is we're not going to do a certain action such as minusing both sides, or multiplying both sides, or squaring both sides, or arc sine both sides, or things like that. We do not want to alter the value of the left hand side and the right hand side completely in when we're in the process of proving the left hand side is equal to the right hand side. Then what are you allowed to do? Well, you're allowed to change the look of it. So you can rearrange the expression, you can factor expressions, or you can do expansion of the expressions. So those are some options that we can take. So let's look at an example that we have here. Let's say we have a proposition like this. We want to prove this identity. We want to prove that the left hand side and the right hand side are equal to each other. So once again, you might be tempted, hey, I have fractions all over the place. So why don't I multiply both sides by m? So I just have 1 on the right hand side. Well, we're not allowed to do that here. So I'm going to do some series of um, arrangement of the expressions. And I think it's quite obvious that maybe you could try to rearrange the left hand side mainly. So the first thing that I'm going to do is I'm going to add these two fractions together. And I think in order to add these two fractions together, I think we need to do find the lowest common multiple of the two denominators. And maybe before that, maybe I can try to factor out one of the denominators to make it look more simpler. So let's go 1 over m plus 1 plus, I think m squared plus m can be factored to m times m plus 1. Aha, we already see that we could find the lowest common multiple instead of a regular multiple. So I think the lowest common multiple of the two denominators would be m times m plus 1. And I think I'll achieve that by doing the m multiplying by m for the first fraction, and then the second fraction is just kept the same. Now I think we can easily factor out, or I can reduce the m plus 1 on both sides. So it's going to become 1 over m is equal to 1 over m. Yay! So notice that I didn't change the value of the left-hand side. The left-hand side value is always kept the same, except we only change the look of it. Now, there's some catches that we need to put here. So I think this proof is complete. Um, However, it's only possible for some specific cases of m values. For example, this proof is possible except we have few non-permissible values, right? Remember you learned that in pre-calc 11 class, or when you learned about the rational function. This equality is not possible if m is not equal to -1. If m is equal to -1, then this equation, this identity is not true, right? Because the left hand side will be undefined, whereas the right hand side will be defined. However, I think if m is 0, I think that'll be fine because we'll have undefined case. So, noticing that non-permissible value, we're complete with this proof. So there are a couple of things we can write when we want to finish a proof. For example, we can try to put a little square box on the lower right hand side. This is kind of like a period in an English language to finish a sentence. So when you finish a proof in math question in math, we put a little box like this. Another one we can do is we can say QED. QED is a Latin phrase, and it means uh, as was demonstrated. So it means that, hey, I did it, I did my work, kind of thing. All right, so this is the first case of proof, and this is called proof by deduction. Obviously, it could be useful if you have an equality, like if you're trying to prove a trig identity, which usually looks like an equation, then we can try to use the proof by deduction method. All right, next video we'll be seeing the other cases of proof.